For centuries, surviving off the land relied on a combination of brute force and looking at the sky. Humans observed weather patterns, hoped for rain, and compensated for uncertainty with physical labor. Moving water to where it was needed meant endless repetition. Without precise environmental data, farmers pulled moisture from wells and streams using wooden wheels and draft animals, guessing how much hydration their crops actually required. This created a system driven by static logic. Seeds were planted, watered, and harvested on a rigid, inflexible calendar. If it was Tuesday, you watered the field, regardless of what the soil or the atmosphere was actually doing. That rigidity creates massive vulnerability. When an unpredictable climate shift occurs, like a sudden heat wave or a prolonged drought, a farm running on a fixed schedule has no mechanism to adapt. The crops dry out and the system fails. Industrialization eventually brought us the mechanized pump and the high-pressure sprinkler. But these machines didn't fix the underlying problem of static logic. They accelerated it. Modern agriculture is an open-loop system. A timer turns a pump on, but zero soil feedback turns it off. Blind to ground conditions, the pump floods the field even when saturated, wasting millions of gallons of fresh water. That excess water physically degrades the land over time. It washes away topsoil, leaches valuable nutrients deep beyond the root zone, and ultimately drowns the crops it was meant to sustain. To survive extreme weather events, laying down larger pipes and stronger pumps won't work. Agriculture doesn't require more plumbing, it requires a functioning brain. The fix is a closed-loop framework powered by the Internet of Things and real-time environmental data. This is what we call smart agriculture. Satellites like Landsat 8 gather false-color composites from orbit, using thermal infrared sensors to continuously measure land surface temperature. Additionally, these NDVI maps pinpoint geographical zones of healthy crops versus areas suffering severe water stress by measuring reflected near-infrared and red light. Down closer to the surface, autonomous drones run image-based computer vision algorithms to scan the leaves. They detect microscopic signs of crop disease long before a human farmer notices a problem. This network provides a high-resolution map of every variable on the farm. But those numbers are just noise if they aren't connected to a decision-making engine. This diagram outlines the core of that engine, the microcontroller unit, or MCU. It sits at the center of the wireless sensor network, aggregating data from every corner of the farm to act as its central nervous system. Using machine learning, the MCU replaces static logic with probabilistic reasoning, calculating the exact likelihood a plant needs water or nitrogen. It then triggers specific valves, delivering precise microdoses only where required, bypassing healthy plants, completely closing the feedback loop. This closed-loop intelligence completely eliminates the need for human guesswork. If a sudden heat wave spikes soil temperatures, the system reacts instantly, adjusting flow rates without anyone having to manually turn a valve. By closing the loop, the farm effectively manages its own biological survival, turning it into a system that stays responsive to its environment 24 hours a day. The immediate physical impacts are massive. Farms see a drastic reduction in wasted freshwater, zero chemical runoff into local streams, and perfectly optimized crop yields. The role of the farmer evolves as well. Instead of acting as a manual laborer performing repetitive tasks, the farmer becomes a strategic supervisor, monitoring the AI's closed-loop decisions remotely through a mobile interface. This real-time responsiveness buffers the farm against the shocks of erratic rainfall and sudden heat spikes. It keeps yields stable in volatile environments, where traditional, static systems would likely collapse. Integrating probabilistic intelligence into the field makes the land a responsive, data-driven system, ensuring our food supply can withstand whatever the climate